Welcome to another episode of AI Frontiers. Today, the focus is on groundbreaking research in computer vision, synthesizing insights from 37 papers published on May 1, 2025, sourced from the ArXiv preprint server. This episode offers a deep dive into the latest advancements, spotlighting real-world applications and technical innovations that are shaping the future of how machines interpret visual data. Stay tuned as these fascinating developments are explored in detail. To begin, let's define computer vision, a pivotal subfield of computer science. It's dedicated to enabling machines to interpret visual information, much like the human eye and brain collaborate. This involves processing images and videos to recognize objects, detect patterns, and even predict behaviors. Its impact is vast, powering technologies such as facial recognition in smartphones and autonomous driving systems. Beyond that, it transforms industries like healthcare through medical imaging and agriculture via drone-based crop monitoring. The 37 papers under review today illustrate the remarkable diversity and innovation within this field. One prominent research theme from these papers is text-to-image and multimodal generation. This area centers on creating visual content from textual descriptions or integrating various data types, such as images and depth information. A notable contribution by Zhang and colleagues demonstrates significant improvements in aligning generated images with text prompts, achieving higher semantic accuracy. Such advancements hold promise for intuitive AI solutions in design tools and media content creation, paving the way for more creative applications. Another key theme is 3D vision and reconstruction, which focuses on constructing three-dimensional models from two-dimensional inputs. A pioneering work by Zhang and team introduces Razor, a self-supervised model for 3D synthesis that reduces reliance on costly labeled data or precise camera information. This breakthrough has implications for virtual reality, gaming, and autonomous navigation, showcasing how AI can emulate spatial understanding with minimal input requirements. Computer vision also addresses significant societal challenges, forming a crucial research theme. For instance, Rajesh and colleagues utilize vision technology to optimize the placement of air purification booths in polluted urban areas. Additionally, advancements in medical imaging enhance disease detection through MRI scans. These applications underscore the growing role of AI in promoting public health and sustainability, highlighting how visual intelligence can solve pressing real-world problems. Turning to technical foundations, convolutional neural networks, or CNNs, remain a cornerstone of image processing in computer vision. These algorithms mimic human visual pattern recognition, excelling at detecting local features like edges and textures in images, such as those used in X-ray scans. Widely applied in object detection and classification tasks, CNNs are foundational to many of the papers reviewed. However, they often struggle with capturing long-range dependencies in images, presenting an ongoing challenge for researchers. Several key findings stand out from this batch of research. Zhang and team report a 13 to 19% improvement in text-to-image generation benchmarks, setting new standards for accuracy. Another study by Zhang and colleagues demonstrates self-supervised 3D synthesis that rivals traditional supervised methods. Rajesh and team offer innovative solutions for urban air quality management, while Zhang and colleagues introduce valuable datasets to advance medical AI research. These breakthroughs span creative, spatial, and societal domains, pushing the boundaries of computer vision. The methodologies driving these innovations are diverse and sophisticated. Deep learning with convolutional neural networks excels at local feature detection. Transformer-based models capture global image context, particularly in areas like remote sensing. Diffusion models refine noisy data into clear images for generation tasks, while reinforcement learning optimizes dynamic scenarios such as booth placement. Additionally, self-supervised learning reduces dependency on labeled data, offering a cost-effective approach in many vision tasks. Among the standout works is a seminal paper by Zhang and colleagues titled T2IR1, focusing on text-to-image generation. This study enhances image creation from text prompts by combining reinforcement learning with a chain-of-thought reasoning process. The results show a 13 to 19% improvement over existing benchmarks, surpassing competitors. This innovation promises to revolutionize design and media content creation by achieving superior semantic and visual alignment, marking a significant step forward in generative AI. Another remarkable paper by a different Zhang-led team introduces Razor, a self-supervised model for 3D vision synthesis. This work synthesizes novel 3D views from uncalibrated 2D images using a transformer-based framework, matching the performance of supervised methods without requiring camera data. By breaking barriers in data dependency, Razor democratizes 3D modeling, offering potential for augmented reality and autonomous navigation applications. A third seminal paper by Rajesh and team tackles urban air quality management using a deep reinforcement learning framework. Focused on optimal placement of air purification booths in polluted metropolitan areas, this approach employs multi-objective optimization to outperform traditional placement strategies. The impact is profound, addressing public health challenges in densely populated cities and demonstrating the practical relevance of computer vision in societal solutions. Another technical insight comes from the use of diffusion models in computer vision. These models gradually transform noisy data into clear images, proving effective in tasks like image generation and super resolution. While they deliver high-quality results, their training process can be slow, posing a challenge for scalability. Featured in studies on part assembly and video analytics, diffusion models represent a growing trend in generative vision technology. Looking to the future, several directions emerge for computer vision research. Efficiency remains a priority, with efforts aimed at developing lighter models suitable for everyday devices. Generalization is also critical, ensuring systems perform robustly in unpredictable environments. Ethical considerations, such as addressing bias and privacy concerns, are increasingly important. Additionally, integrating vision with language processing for multimodal AI systems, alongside a continued focus on societal and environmental solutions, will likely shape the field's trajectory. In conclusion, the insights from these 37 papers published on May 1, 2025, highlight the dynamic state of computer vision. Breakthroughs by Zhang, Rajesh, and others redefine what's possible, with diverse applications ranging from creative arts to urban health solutions. Challenges like computational efficiency and ethical implications remain critical areas for attention. This synthesis was created using AI tools, including GPT-Grok model Grok 3, with text-to-speech via Google, images sourced from Google, and reviewed by a human expert. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from ArXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights.